So previous chapter, we were talking about the superclass, subclass. We would have a superclass, and then we had a bunch of subclasses, and these subclasses can be created as we go along. So the superclass wouldn't know who's going to create a subclass tomorrow or next month or next year, wouldn't know it's not aware of the new ones coming up. And we can have many of those things. And generally what we talked about is if we have some common things that we have in classes, we're going to take those comments and we're going to put it in the super. So we are not going to be, we're going to be using less coding, reusable code. So if I have classes that they have something in common, I take those common things and put it in the super class, and then I create the subclasses of that. Now, in this chapter, we're even going to extend that to different objects. So far, we were talking about having some common areas of the same types of classes. Now we're going to talk about how we're going to extend this to different types of classes, different objects. So why do we need that, and how we're going to do it? And the whole idea is about the reusable code. So your book is talking about, and one of the reasons I like about this book is has those little pictures. So it's talking about in this picture that as far as you pay me and you want to eat, as far as you want to eat and pay, you are my customer. So you can be somebody can bring a cat. As far as it's paying and eating, I'm okay with it. So the interface for the customer is eating and paying. It doesn't matter what it is. A better picture of it is coming out to, so we are talking about creating a one method that provides service for different objects. So where was the first picture that I want to bring? What is that picture that I do? So there is a picture over here. I don't see it. Okay, let's look at this machine. So this machine is capable of rotating things. So we can potentially change the what is rotating to another one, and it's going to do different tasks. So the machine is going to provide rotation, and we can use that rotation for different tools, different way of doing things. So when we buy this machine, they're going to have multiple things that I can use it in this machine, and I can change it. So that is what's going to happen to this. So they're going to have an engine that's going to be making some movement that can be passed to transmission. Now, they can put this engine in a car, and it's going to move the car, and they can take the same engine and put it in a small plane, and it's going to make the plane to fly away. So the job of the engine is just making some kind of a rotation, and that's what we're talking about here, that we're going to have some service that's going to be available for multiple objects. So let's think about it through an example. In here, we are thinking about a method that's going to be computing the average. So we're going to create a generic method that's going to compute the average, and then we're going to accept different objects, and we're going to do the average for different objects. Now, somewhere, somehow, we have to figure out what is the number that I'm going to be making the average for. So if this is going to be students, am I making the average of the age of my students? Am I making the average of the grade of my students? And if I take this average and go with the classroom, then am I doing the average size of the classroom? And now I take the average and I go with some other object. And this, as far as give it the number, so somewhere, somehow, the object has to give me a number or series of a number, then I can create an average of them. But the first thing first is the object has to give me a number to be able to do my average. So we are going to be creating some way, some method that's going to be doing that service for us. That would be the average. And then we're going to find a way to, for example, if I have a bank account, I'm going to do the average for my balance. If I have a country, I'm going to do the average of their area. So somewhere, somehow, these objects that's coming into me, they have to give me a number. So we're going to create something called whatever we want to call it. In this case, it's called get measure or get a number or whatever we want to call it. And all of these objects that they want to use my average have to have this method. So when I call my average for the object, I'm going to call this method and I'm going to get the number that I need to calculate my average. So my bank account get measure is going to give me the balance. My country get measure is going to give me my area. My students get measure is going to give their ages. My classroom get measure is going to give it the number of seats. So I can use this to any object and they're going to give me a number. As far as I have the number, my average can be run. So the only requirement that I have is if you want to use my average, you have to give me a number. Now, how do we implement this? So I can easily do a sum plus the object that's coming to me, call the get measure to get the number, then I have my sum, and then I can divide it by the items that I have in there and create my average. So this is going to be generic. So we're going to have different objects coming into me. I don't know what objects are coming. All I'm requiring is give me a number. So in here, we call it get measure. I might call it give me a number or whatever you want to call it. So we put that in the interface. Remember that when we have a interface, then we can we can extend it, or we can get the interface, and then we have to do that method. So we do not have any implementation for this. The implementation is going to come into the class that's going to implement it from this interface. So we're going to create an interface that would be something that I need from every object that they're going to use my services. And I want to be sure that all those objects are going to have this method. So we create our interface. We're going to call the method in there without any implementation, because the implementation is going to be different in different objects. So it is similar to a class, but it's not a class. So the interface does not have any instance variable. So the methods are automatically abstract. That means what? The subclass has to implement that method. In the newer version of Java, that's going to be static. They have a name, a parameters, and return type, but no implementation. And it is automatically public. So it's not. So all of the methods are automatically public. I don't have to say it. And again, Just like the abstract, we do not have the constructor for it. So you cannot create an object of interface. Okay, now that we put that on the side, now we told every object that they want to use my services. They're going to have that method to give me a number. Now I'm going to be writing my own service that I'm going to give it to them. So this service is called average. And we're going to get a list of objects coming to us. And we all agreed upon that no matter what objects you're going to give me, you will give me a get measure. So we all agreed that no matter what object is coming in, you're going to have the get measure in it. So I can use a for loop, go through the list, get my measure from each object that I have in every item. Remember, the type is object. So that means I can have any object, and they're going to give me that get measure. So I'm going to get a number from it. I'm going to add it to my sum, which was 0. And then I check the size of my list that's coming in. As far as it's greater than 0, so there is a possibility that somebody is going to pass me a list that doesn't have anything in it. And if I don't check it, then I'm going to be dividing by 0. And I don't want to do that. So I'm going to check. These are the things that I have to check. I have to think about it. I'm going to check it. Be sure it's greater than 0. I'm going to get this sum. I'm going to divide it by length. And if it is 0, I'm just going to return 0. So this is the service that I can provide to any object that you want to give me, as far as you have that get measure in it. So any object that you give me, as far as is a type measurable, remember we created interface for them. So the example here is, again, we talked about it, that this machine is going to have a rotating things, but it can replace this part with different one as far as the rotation. The machine is just providing rotation, and this part can change in different types, different ways. Are you following me? You're falling asleep?
So what are the primary reasons to incorporate an interface?
So the primary reason is reusable code.
Okay.
So if I can have a generic average, and you're going to see this as you go forward with
so isn't
Java,
this like
of course,
a
it's going to
template?
happen. It's going to happen more into the data structure. That's why I strongly suggest you guys take the data structure in Java, because it's going to provide these things. And we're going to see that at the end of this. So I'm going to have an average. So any objects can use this average. I don't need to create an average. An average is a small thing, but let's say we have a method that we want to use it for all of those things. Reusable code. So in the previous chapter, they had to be the same type. In here, they are not the same type. So I'm going to give you a service that you can use as far as you tell me what I need. Okay, so remember, we created the measurable as an interface. So anybody who wants to use my average have to have this implement measurable. Measurable was what? To give me a number. So my bank account, remember, all of them have to have this method. So when you say implement measurable, that means inside of your code, you have to have this method. This method is going to return me a double number. So when I'm in the bank account, it's going to give me a balance. So I am in the class of bank account that implements measurable because I want to use that average. So this one is going to give me a balance. So when I create a new object of the bank account, it's going to have this method in it. Okay,
So
so
what's the difference between using the keyword implement and extend?
extend is for inheritance, implement is for interface.
Okay.
Okay, now we had the bank account. Now we want to do another object totally different. In this case, it's going to be a country. So if I want to use that service of average, my country has to be type of measurable. That means it has to implement measurable. So in my country, I'm going to have a method called getMeasure that's going to return double. In the country, it's going to return area. In the bank, it was returning the balance. In my student, it was returning the grade, the total grade. In the classroom, it was returning the size. So I can have different object type. All I need is this method in there. Now, that's the whole idea, to make more reusable code. So I'm going to write one method. All the objects are going to be using this method. To make it easier to follow, remember, every time we create a class, we want to focus on one topic, one thing that we're going to be focusing. So to make it easier to follow and easier to understand, we're going to separate these things. So we're going to create a class that's going to do the actual services. We're going to have an interface that's going to tell what is this service needs, so we can give it to it. In this case, it's going to be a number, or it can be some other things. So this interface is going to talk to the objects that's coming in, that they're going to provide something that we're going to give it to this class of services that's going to do whatever we need to do. So we're going to have two classes for what we're doing, and then the objects are going to have their interfaces. Whatever object you have, then we can get this working. So whatever we have in this class, it's not going to be repeated to all the objects that we have. And this is the basic concept of containers for Java, that how they can provide something that's going to work for many objects. So you don't have to write the code again and again and again. Okay, so we're going to separate them. And now we're going to look at how it's going to happen. One thing that we have for interfaces, you can have more than one. Remember, in inheritance, when you're doing extend, you can only have one. But for the interfaces, you can have more than one. So you can have measurable, you can have some other ones, so you can use different services from different areas. Now, this is the service that I'm going to give to all the objects that are going to come to me. So if you send me any list of objects, I'm assuming that you're going to have the getMeasure in there, and I'm going to provide you the average. You do not to have the average in your main to calculate the average. Remember, if I didn't have this code over here separately, in my main, I would get the balance of the account, figure out the average for balance. For a country, I would get the area and then figure out the average for the area. Now I am putting this here. They don't need to have those average. Remember, this is just an example. You can have a lot more than that coming up. So this is my interface. My interface is just going to have this. It's going to return a number for me. So now that I have this interface, any object that wants to use my service has to implement this one. So let's look at this. So I have my country that implements measurable. That's the one that I just showed. So that means inside of this, I have to have a method of get measure in the country. That's going to return area. Now, in my bank account, which also implements measurable, I am going to have a method that's called get measure. So every object that want to use my services, they have to have this get measure. And how do I enforce it? They have to have implements measure. Now that I have these things, then I can make it work. So how does it work? I'm going to create a, remember, we can have a type measurable that we can put these things in it. So if I have an interface, my class can be of that type. That is a generic way of saying it. So I am having accounts. I'm going to create 3 of the measurable, which is going to be okay for the accounts. So I'm going to put 0, 10,000, and 2,000 for these 3 accounts that I have. And then I'm going to call the average. Remember, it's a static. I don't have to create an object for my data. I can just call it. So I am calling the average, and I'm passing the accounts that I created over here. And then it's going to return me the average balance. Now, I can do the same thing with the country. I'm going to create 3 countries. I'm going to pass the country to the average. Remember, I'm not writing the average again. I'm using the one that I have. And now it's going to give me the average of the areas of these countries. If I create students and I pass it in here, it's going to give me the average grade or age of my students. If I pass the classroom, it's going to give me the average of the size of my classrooms. If I give the, I don't know, cars in there, that they have some kind of a numbers in there, so they might give me the average size of the cars in the PCC parking lot. So I can pass any objects here, and any object that I pass is going to give me the average of whatever that number is coming out of that object. It's a complex point, so you guys need to spend some time on it to really understand it, but it is very useful. We are not going to, we're going to use some of it. So the question that Jose had, what's the difference between the interface and inheritance? So we can have more than one interface. Inheritance can be only one. We can only extend inheritance to a single superclass. So the implementing should be done in the subclass. Superclass has some implementation for the method. When we're doing the interface, we don't have any implementation in the interface, but in the superclass, we do have some implementation. We can create an object of the super, but we cannot create an object of an interface. So we are going to be creating interfaces when you have code that processes object of different classes in a common way. So if you have different ones in a common way, we're going to use this.